We have built Lux Blox structures to represent different molecular geometries. Here we have the structure of carbon dioxide with two bonding electron groups around the central carbon. It is linear with a bond angle of 180 degrees. Here we have a structure of a carbonate ion. It has three bonding electron groups around the central carbon with a trigonal planar geometry and a bond angle of 120 degrees. Here we have representation of sulfur dioxide with two bonding electron groups around the central sulfur and one non-bonding electron group represented by this large sphere here. It has a bent geometry and a bond angle of about 120 degrees. Here we have a model of methane with four bonding electron groups around the central carbon with a tetrahedral bonding geometry and a bond angle of 109.5 degrees. Here we have a model of ammonia with three bonding electron groups on the central nitrogen and one non-bonding electron group represented by this large sphere. And we have a trigonal pyramidal geometry with an angle of about 109.5 degrees. Here we have structure of a water molecule with two bonding electron groups around the central oxygen and two non-bonding electron groups represented by these large spheres. And this is a bent geometry with an angle of about 109.5 degrees. Here we have a model of phosphorus pentafluoride with five bonding electron groups around the central phosphorus. It has a trigonal bipyramidal geometry with bond angles of 90 degrees and 120 degrees. And we have a model of sulfur hexafluoride with six bonding electron groups around the central sulfur with an octahedral geometry and an angle of 90 degrees.